They will be able to see us now and at question time through the camera, so wave. Hi! Hello.
Hello.
Are we all ready to go over there?
Yeah, I'm all set.
Excellent.
Just give me a word.
Have at it.
Thank you. Hello, everyone. My name is Syed Muhammad Dawoud, and I'll be talking today about N+1 problem in Django Rest Framework here at PyCon AU. Very excited to be here, even though remotely, but still it's my first time at PyCon AU, so pretty much excited. Uh, So our agenda today is like just a brief of what is Django REST framework, and the rest of the talk will focus on like what is N+1 problem, how it can happen within Django REST framework, how do we identify these problems in our APIs, and how do we resolve these problems. Uh, Before I jump into the content, who am I? Again, myself, Syed Muhammad Dawoud Sheraz Ali. I am a software engineer by profession, and currently I am working as a contractor with Arbisoft at Lahore, Pakistan. So Arbisoft is mainly a service provider company, and we have a diverse set of technological skills. Primarily, I've been working with Python and Django for the last couple of years. As part of Arbisoft team, I've been working with edX/2U as Arbisoft contractor. Apart from that, I have been involved with a few internal products development within Arbisoft. If you want to get in touch with me over LinkedIn, read something that I have written on Medium, or see my GitHub, the links are here. I'll share the slides link at the end of the presentation. With that out of the way, let's jump into the content, starting it off with Django REST Framework. So if any of you worked with Django over the last decade, it's highly likely that you got to interact with Django REST framework in one way or another. Uh, like with the advent of cloud and single page applications, we have seen rising popularity of Django, and APIs develop on Django backends using Django REST framework. What's beautiful about Django REST framework is that it is built upon the core Django features, and it integrates really well with them. So for instance, how we expose our APIs using URLs and views, it's all built upon the Django's views and URLs framework. Using Django models, we can easily create serializers. So how serializer are like how we represent data in JSON and other format. DRF also take care of deserialization. So in a sense, if we are getting data in form of JSON or some other formats, it does the job of converting that JSON into appropriate model objects. Mainly DRF is used for API development, and for that it provides a variety of options in how we design our views. If we want to write a complete API from scratch, we can utilize API views. But if we have serializers, we can use view sets and generics to set up an API within like 3 to 4 lines. And lastly, using custom authentication and permission, we can easily add layers of controls on our APIs. So in that regard, DRF makes things really easy in how we can design APIs using Django. So moving forward, like what is N+1 problem and how does relational database come into the play here? So in typical RDBMS like MySQL or Postgres, uh, how we represent real life objects is in the form of tables. So our data model is scattered across different tables, and the tables are connected or related to each other via some sort of relationship, be it one-to-one, one-to-one, one-to-many, or many-to-many. And we join these tables to get the complete information of an entity. So let's say for this example, we have a customer that can order a bunch of things, and within an order there can be multiple products. So if we want to get the entire order information of a customer, we can do that in two different ways. First way is that we get customer information from the customer table. Based upon the customer ID, we can get all the orders made by that customers, and then based upon order IDs, we can get all the products. The second way of doing that is simply join the tables using foreign keys, and then get all the required data in one or two queries. So these are two different ways of achieving the same thing. In first method, we are making one query to get the main object, and then for each related object, we are making a separate query. So one query for main objects, and then for each of the related object, we are making separate queries. So it's one plus n queries or n+1 queries. The second is we are just joining the tables and getting all the information. So the question here might be, okay, both methods are like doing the same things in a different way. So why is n+1 an issue when it comes to RDBMS? It's not really an issue on the DB level, but when we involve our ORMs or object relational mapping, that's where n+1 becomes a problem. So Django is an ORM, SQL Alchemy is an ORM, and with ORM we can do a bit of abstraction in how we design our database. So we define our models using ORMs, and then ORMs take care of generating the appropriate table, adding the appropriate relationships when we want to fetch something. ORM takes care of all of that. So all of the heavy load of connecting with like database server, getting the information, that is handled by ORM. Uh, why is n+1 problem in here is that ORM has to make a DB round trip for each query. So let's say if, for the previous example, if a customer has 100 orders, so ORM might be making 100 plus queries to get the information for one customer. The individual queries might be fast, but it's the accumulation of all those queries that becomes problematic. So essentially, the more queries are there in the fetch operation, the more round trips to the database will be made by ORM, and the more round trips are there, the more load will be putting on our database servers and causing performance issues. So because of how ORM works, that's why the n+1 becomes a performance complication or performance problem. Okay. Moving forward, I'll be using this example for to explain all of the things in DRF. Uh, on online resources, the author and book example is used a lot to explain the n+1 problem, and that is why I'm using that example here as well. So in this, we have an author one-to-one with Django user. Uh, Author can write multiple books. Book can be of a category, and we can add tags to books like New York best time seller, #1 seller, etc. So it's like really simple model, nothing complicated. The idea here was to show different type of relationship that we can have and see how n+1 impacts them. So on author, we have one-to-one with user, many-to-many with specializations. On book, we have a foreign key to author, foreign key with category, and many-to-many with tags. And the APIs, two APIs that we'll look is listing all authors with their books, and list all the books including the person who authored it. So like we are doing similar things, but there will be operational differences. It's just a screenshot of this APIs in action. So on the left side is the authors listing, where we are listing the authors details and the books that they have written. On the right side is the book listing, where we are adding the details of books including the author information. But here we won't be having the books information again, so it's already up there. Why I'm using listing? Because in listing we are fetching objects in bulk, and it's really easy to demonstrate what's going on behind the scene with listing. With retrieval, identifying N+1 problem might be tricky, but with listing, it's really easy to see what's going on under the hood. So let's start off with like how N+1 can happen with DRF views. Uh, in here, we'll be more focused on the generic and model view sets that DRF provides. In both of these options, we require a query set to return our necessary objects. So query sets in Django terms is just a collection of DB objects. They can be 0, 1, or many. We can either set a value for query set attribute or override get query set method. So it's that query set that defines how or which model will be used to get the objects from. So let's say for both book and author listing, we are just adding book.objects.all or author.objects.all, and it takes care of listing all of the entities. So you can see like it's really easy to, within 3 or 4 lines, we have set up an API view, but there are things happening at the back. Now the problem with query sets is that they are lazy, like lazy loaded. DB won't be hit until the object is really needed. So it does not prefetch the information. Once we require that information, that's when DB will be hit to get that information. So it holds true for the main object, the related object on the main object, and the related objects on the related object. So for every case, unless the object is not needed, it won't be retrieved. So this query set behavior is something that seeps into like DRF views and cause problem complication. So let's say if we take this example, book.objects.all. If we want to print out the book author's username, for each book we'll be hitting the database because the query set would not have prefetched the author information. So let's say if we have 100 books, we'll be hitting at least 100 times to get the author information for each book. So like that's a problem with query set, but that impacts how DRF views are written. Similarly, on the serializer level, serializer are like how we define how the objects or its related objects will be represented. On serializer, we can also use query search for certain type of fields. So let's say if I'm getting the tags information, I can define the query set from where this information will be fetched. And this is like specific to certain fields where we can use query set or source attribute. So source attribute is where we define which attribute to read the information from. So let's say I'm getting the author information and we need the email. I can tell that, okay, read email from user.email. And same is the case for username. Now for both of these operations, if these have not been prefetched, these calls will result in additional DB calls. So if we are listing, there will be like N+1 on the query set, and also N+1 on the serializer level as well. So unless we have prefetched the user information, using such configuration can result in additional DB calls when we are fetching information. So like the fields that take source and query set attributes are prone to N+1 issues. So if like again the related object is not already prefetched, it will cause additional database calls. And again, the behavior is that because query sets are lazy, they do not fetch the related object unless we need those objects. So when we are writing APIs, be it in Django or DRF, how can we know that the code that we are writing has N+1 problems? So like what again, I'm using listing to showcase this. On local, we might not have that much of data to see what might be going wrong here. So for to identify N+1 problems, we have a few tools that we can use. One is N+1. The second is Django debug toolbars. So both of these are the packages that can be easily configured with our Django applications. N+1 is a package specific to detect N+1 problems. So it like analyzes the application logs and logs the potential N+1 issues that might be happening within the application. It does not tell where that issue is coming from. It just logs out that on certain fields there might be N+1 problem. This package is not actively maintained, but it still works. So that's plus one about it. Uh, so using the same package on both our books and author listing endpoint, it will just tell that there is n+1 query on book.textset or type field, author field, same for the author.user fields, author.books field. It does not tell where this n+1 is originating from. So that's why it is better to test each API in isolation. So take one API, see how n+1 is responding against that, and try to figure out where the n+1 might be coming from. Django debug toolbar is like a very important but much more heavyweight package than n+1, because it is used for debugging the entire Django apps, and it outlines much more information. So it's like what Django version are using, what SQL queries are being executed to get that information, how many signal or signal handlers were executed. So it provides much more information. For us, SQL queries are important in identifying N+1 problem. So if we see a lot of duplicate queries where the queries are same but the filtering criteria is changing. So let's say we are only changing IDs. So we are making 100 same SQL query was only the IDs changing. That indicates that there might be N+1 problem with that endpoint. So like here's the output for the authors listing. So Django debug toolbar indicates that okay, 197 queries were executed. There are 195 similar. So it's telling there are duplicate queries here and there, and we can identify just looking that okay, we are getting user information, ID is changing, we are getting specialization, the ID is changing. So these duplicate queries are an indication that we are hitting DB more than we should. Same is the case for the books listing. There are like 53 queries and there are 51 similar, and we can see the pattern here as well, that we are getting user information, ID is changing, category information same, the queries is same, but only the ID is changing. So it is a repeat queries that is indication that there might be n+1 problem here. So we can use both of these tools to like see if there are n+1 problems on our API. But once we have identified the n+1 problems, how do we resolve those problems so that we are not hitting DB and for more than it's needed? This is something that is provided by Django. Where we can there are two uh, methods that we can use on query sets: select related and prefetch related. Select related is used to fetch our foreign keys or one-to-one relationship when we are fetching the main object. So it does a join on SQL level and gets the main object and the one-to-one and foreign key relationship in a single query. And the neat thing about is that we can also fetch the related objects in that same call as well. So we can use one query to get the entity information. So previously we were doing book.objects.all. Now we can change it to book.objects, and then we can specify which relationship to fetch alongside book. So we can like fetch the author information, author, user information, book type, and once we add that, we can see a difference in the log of n+1, where previously uh, it was telling that type and author have n+1, Now it's just telling that tag set as n+1 problem. So by using this simple uh, method, we have reduced the n+1 to only one field. And we can also see a reduction in our SQL queries, that now uh, there is one join operation that's getting the book information, author information, and author user information. So all of that is happening in a single query. There are still duplicate queries that will be resolved in upcoming slides. We can use the same select related for on our author listing as well. And again, there will be reduction in SQL queries here as well. So where previously there were 53 queries for book listing, with select related, that count reduced to 23. For author, we are down to 139. Prefetch related is like used to get our foreign reverse foreign key or many-to-many relationships. The difference with prefetch related is that it prefetches the required object via SQL query and then performs the join operation in Python. So select related is doing the join in DB level. Prefetch related is doing the join on our Python level. So that's a big difference here. The idea is that since with many-to-many relationship, we have an intermediate table. So when we are joining three tables for like one many-to-many relationship, the resultant table that is like obtained after all the joins can become very huge, and that can cause uh, problem issues in itself. So for that purpose, the many-to-many or many-to-one join is performed in the Python code base. So if we go back to our book listing, we can chain these operations. So after select related, we can prefetch related the tags information and like author specializations. And the result of that is we are getting all the information in like 5 queries. So where there were like 50 plus queries or 100 plus queries, now we are getting that information in 5 queries. So we can see the drastic difference here. Uh, the thing I'll focus here is that we can see that we are fetching like tags or specialization against special or certain IDs. So like these will be all the authors that we have fetched, and only those specializations will be fetched, and then Python Django will take care of the internal join operation. Same is the case on the author listing. We can chain all of the operations and then see the output of that we're doing all of the fetching in 7 queries. So if we compare SQL queries before and after, uh, previously we were getting all the books in 53 queries. With both select and prefetch related, we are doing that operation with 5 queries. On author, we have gone from 197 to 7. So that's a like pretty big reduction in SQL queries and how many DB round trips that we are making. And this select and prefetch related is something that DRF also recommends using to avoid N+1 problems on both our serializer level and on view level. Uh, the prefetching is something that DRF does not performs on its own, because like it is using query sets and query sets are lazy. So that's why the recommendation by DRF is that use both of these built-in tools and get the required related objects yourself. So they have mentioned that it's the programmer responsibilities to optimize those queries. So again, with DRF, it's really easy to create APIs, but with the N+1 problem, we can see a lot of performance issues when our applications scale. So it's better to identify those problems beforehand and resolve them using select or prefetch related. Okay, we are at the end. So N+1 is like a pretty common problem in both core Django views and DRF views. We would not know the performance impact of these issues like unless our underlying data hits a certain limit. So let's say if we have limited number of objects, both on production or local, we might not know that something is wrong when it comes to fetching information. But once the data increase, we'll start to see the performance implication on our production. So like we can use the tools like N+1 and debug toolbar to identify these problems beforehand and fix them before uh, this problem appears with the scaling. One thing to note is that N+1 fix-ups can result in complex joins on DB level that can sometimes cause negative impacts on the performance. So in the current example, our relationship is quite simple, but there will be uh, real world applications where we might have 20 plus one to one or one to many or many to many relationships. If we are prefetching all of that information in a single go, the resultant join query in SQL uh, might be inefficient or might not be using index. So if your model is a bit complicated, try a combination of select and prefetch related to see which combination yields the best results for you. Uh, you can maybe use caching on certain query sets to uh, avoid hitting the database again and again. So let's say for the book categories, we can use some sort of cache to prefetch that information in the cache and use that cache information. So like the bad try a bunch of combinations and see which yields the best results for you. It will vary on case to case basis. But in most cases, using select related and prefetch related will resolve a lot of the uh, like performance related issues on the RF APIs. Uh, this talk was inspired from a similar talk at Python Web Conference. So it's the talk uh, titled "Finding and Fixing an N+1 Problem in Django Docs." You can like see that the recording of that talk on YouTube. The slides for my talk are present on my GitHub. Same is the case for the code. Here are a bunch of the references for the different terms that we have talked about. If you have any feedbacks, suggestion, comments, like if you were looking for something that I did not add, or if it was a bit too much, please leave a feedback, comment. You can add the questions on Discord, and I'll happy to answer them async. Thank you very much, and have a nice rest of the conference.
I hope you can hear all that clapping.
Yep.
Excellent. Would you like to take one question from the audience? We have time for one.
Sure. Yeah, I can.
If we have one, we can do one. Okay, it looks like most of the questions will be coming to you on Discord.
Got it.
Because even though your talk wasn't on asynchronous, you're going to be asynchronous. Thank you so much.
Thank you.
We will clap again now.